Hi everybody, this is Eduardo Suarez. Recently I came across a video on YouTube that was inspiration for today's topic, that is coordinating motion. I'm going to start by showing you the video and explain you the basics of coordinating motion. As you can see in this video, we have two robots. In order to have coordinating motion, you need to have a leader and a follower. So in this case, the robot on the right that's holding the ball is the leader, and the other robot with the TCP following a trajectory on the ball is the follower. And both of them work together in such a way that the follower robot follows the pattern on the ball with the TCP perpendicular to the surface of the ball. Also, doesn't matter if the leader robot moves, the follower robot maintains the relationship with the leader. We're going to have the two robots in two different motion groups, as we're going to see when we build the work cell. And we need to create coordinating motion group pairs that are going to define the relationship between the leader motion group and the follower motion group. So in other words, the coordinating motion is a motion control method in which the two center point, speed and position of the follower motion group is executed relative to the leader motion group. Here I have the end result of what we're going to do today. So by the end of this video, you're going to be able to do something similar to the video on YouTube. I'm going to run it, and we're going to have something similar to the video on YouTube, where the robot on the right is the leader and the robot on the left is a follower, with the TCP following a trajectory on the ball. You're going to see that first is following the trajectory in the forward direction, and then is going backwards. In order to have coordinated motion, we need to follow a series of steps that are summarized in this list. We're going to go step by step on this list as we progress in the configuration of the work cell. I'm going to start by showing you first the reference manuals that we're going to need for this video. We're going to go to FANUCamerica.com website. We're going to log in to my portal. We're going to go to e-documents, and we're going to search for coordinating motion. You're going to see that the manual that we need is the one that says coordinating motion function operation manual operation. That is version 3.1 at the time of this video. So we're going to need this document, we're going to download it, and also we're going to look for IR calibration. And the reference manual that we need is the IR calibration operation manual operation, that is version 5. Also, if we go to the Authorized System Integrator Network and we look for Friday webinars, there are a couple of excellent webinars that explain the hardware configuration that we're going to need for this application. We're going to go back to the setup list. On the first step, we're going to look at the hardware configuration. I'm going to give you a brief explanation of the hardware configuration. This is normally done at FANUC, and they ship the controller already pre-configured. So this is something that normally you don't have to deal with. The following diagram is an example of a wiring diagram for a dual arm controller, similar to what we're going to use for this application. We're going to have a single robot controller, and each robot is going to be assigned to a different motion group. Each one of the robots has 6 axes, so we need to control 12 axes in total. On the main CPU, you're going to have an FSSB1 car. This is a 12-axis control car, and what you see as black lines represents a fiber optic cable that goes to the amplifiers. So if you follow the line, it goes from the access control car to the 6-channel amplifier inside the cabinet for Robo 1. And then from here it goes to the second 6-channel amplifier located on the cabinet for Robot 2. Also notice that the cabinet Robot 2 doesn't have a CPU. The table below summarizes what you need to answer for the question during the configuration. We're going to have two groups, Robot 1 on group 1 and Robot 2 on group 2. Each robot has 6 axes plus 3 auxiliary axes. In our case, we don't have any auxiliary axes. So Robot 1 is going to start at axis 1 and it's going to take axis 1 to axis 6. And Robot 2 is going to start at axis 7 and it's going to take axis 7 to axis 12, as in showing here. Each one of the robot controllers supports 4 brakes. The first brake by default is for the robot, and the second, third, and fourth brakes are reserved as brakes modules for auxiliary axis. So group 1 brake number is going to be 1, and for group 2 the brake number is going to be 5. Each one of the robot controllers supports up to 4 robots. So for example, if you add a third robot, the hardware configuration is going to be as shown here with a triple arm. What are we doing is just scaling up by adding a cabinet with a 6-channel amplifier, and we're going to have the robot on the third group. Here we have an example of another hardware configuration where we have 5 groups. Group 1 and group 2 is going to be for Robot 1 and Robot 2. And group 3, 4, and 5 is going to be for positioners. We're going to have the main cabinet where we have the CPU, the FSSP1 card. We're going to have the 6-channel amplifier. And on the second cabinet, we're going to have the other 6-channel amplifier. And the total number of axes that we're going to have is going to be 6 for the Robot 1, 7 and 8 that is taken for the positioner. Then we're going to have the next axis is going to be number 9 to 14 for Robot 2 and number 15 for the positioner. So we're going to need an access card capable of 18 axes. Now we're going to go to RoboGuide and we're going to start creating our work cell. We're going to give it a name. We're going to call it coordinated motion. We're going to press next. We're going to press next again. We're going to select the software version. We're going to press next. Over here, we're going to select the robot. We're going to press next. On the additional motion groups, we're going to select the same robot, and we're going to select group number 2. So what we're doing is assigning the second robot to group 2. You can see here that the maximum number of groups that can be supported by the controller is 8, and each group can have up to 9 axes with a total of 72 axes. We're going to press next. Automatically the multi-group motion option package J601 was selected. In addition, we're going to add other option packages. We're going to select Coordinated Motion Plus. It's going to be this one over here. The Coordinated Motion Plus also includes the Coordinated Motion Package J686, so we don't need to select this one. In addition, the Coordinated Motion Plus also includes the IR Calibration Vision Multical J993. We're going to select 2 more option packages. It's going to be the motion package R809. And also we're going to select the IR Calibration Vision Master J992. We're going to press next. we're going to have a summary for the configuration of the work cell with the two robots and the option packages. And we're going to press Finished. When we get to the section, we're going to select the standard flange. Also, we're going to select the standard flange for group 2. Here is we're going to use the table from the hardware configuration diagram that we saw before. So for the FSSB card, we're going to select 1. For group 2, the hardware start axis is going to be 7. The break number for group 2 is going to be 5. And the amplifier number for group 2 is going to be 2. We're going to let it finish creating the configuration, and we're going to have the work cell created with 2 robots in group 1 and group 2 and 1 robot controller. To summarize, this is a list of all the option packages that we have installed. We have the Coordinated Motion Plus R669 that includes the Coordinated Motion package J686 and the IR Calibration Vision Multical J993. If we go back to the work cell and open the teach pendant, we can go to status, we're going to go to type, we're going to go to version ID, and we're going to go to order R5, and you're going to see here the list of all the option packages that have been installed in the robot controller. We're going to go back to the setup list, and we have completed with step number 1, 2, 3, and 4. For step number 2, we don't have a positioner, so instead we did the configuration for the robot on group 2. We're going to go to the work cell, and on the cell browser and the robot controller 1, we're going to have group 1 and group 2. We're going to select group 1, we're going to right click, and we're going to go to properties. And we're going to change the name to Robot 1 Follower. We're going to press apply and OK. We're going to select group 2. We're going to right click. We're going to go to properties again. We're going to change the name. And also we're going to change the location. Right now the 2 robots are overlapping. So we're going to press apply. And the robot's going to move position. And we're going to press OK. We're going to continue with the list. So the next step is going to be master and calibration of the robot and additional motion groups. For that, we're going to need the IR Calibration Beam Master option package installed. So what we're going to do now, we're going to do the robot mastering, and we're going to use vision mastering to get a more accurate result. We're going to divide it into sections. We're going to do the group 1 vision mastering first, and then the group 2 vision mastering. So for that, we need to prepare the work cell to do the vision mastering. We're going to select fixtures. We're going to right click. We're going to add a fixture, and we're going to select CAD library. We're going to select table, and we're going to select this table over here, and we're going to press OK. We're going to select the general tab, and we're going to change the name to table. We're going to change the location, and we're going to press OK. We're going to select parts. We're going to right click. We're going to add a part for the CAD library. We're going to select fixtures. We're going to go to vision, and we're going to select this calibration grid that we have over here. We're going to change the name, and we're going to press apply. Now we're going to insert the calibration grid on the table. We're going to select the table. we're going to go to Properties. We're going to select the Parts tab. We're going to select the calibration grid. We're going to press Apply. And we're going to edit the position. We're going to select 1 millimeter for C. And we're going to press Apply. So you're going to see now that we have the calibration grid on the table. We're going to select Parts again. And we need to create a bracket. So we're going to right click. We're going to select Box. We're going to change the name. We're going to change the color. And we're going to change the size. We're going to press Apply and OK. Now we need to add the bracket to the user tool for the robot. We're going to select the robot 1. We're going to expand it. We're going to select the tooling. We're going to select the user tool number 9. We're going to go to Properties. We're going to select the Parts tab. And we're going to select the bracket. We're going to edit the position. This is going to be 50 millimeters on the X and 25 millimeters on the Z. We're going to press Apply and OK. We're going to zoom in and you're going to see that we have the bracket over there. We're going to move robot 2 out of the way. So now it's more clear that we have the bracket on robot 1. Now we're going to add a camera. So we're going to select again the user tool number 9. We're going to right click. We're going to go to Add Vision Sensor Unit. We're going to add that to the camera. And we're going to select CAD Library. We're going to scroll down and we're going to select this camera over here, black and white. We have the camera attached to the user tool 1. We're going to right click now. We're going to go to Properties. We're going to select the General tab and we're going to change the location. We're going to select 165 millimeters for X. We're going to select 20 millimeters for Z and we're going to rotate 180 degrees on W. We're going to select the Setting tab. We're going to keep the focus length to 12 millimeters. We're going to select the View tab and we're going to change the height to 810 millimeters. We're going to press Apply and OK. So now we have the camera attached to the NRM tooling for user tool number 9 and the field of view is on the calibration grid on the table. We're going to save it. The next step is going to be connecting the camera. So we're going to select the vision over here. We're going to right click and we're going to enable the vision simulation. When we do that, we need to reboot the robot controller 1. So we're going to press OK and we're going to do the reboot. We're going to select vision again. We're going to right click. We're going to go to Vision Properties. And now we need to connect the camera. So we're going to select the port 1. And on devices, we're going to select the camera 1 that we have on the user tool number 9. We're going to press Apply and OK. Now we're going to do the vision mastering in Robot 1. We're going to open the Teach pendant. We're going to press Menu. We're going to go to Utilities. And we're going to select IR Calibration. We're going to get the menu for the IR Calibration. And we're going to select Vision Mastering. We're going to go through the procedure, but I'm not going to give you much details over here. I have a video that covers the subject in much more detail if you're interested in. For that, you can look at the Vision Mastering video on my channel. We're going to select Vision Mastering. We're going to press Detail. Here you're going to see the Vision Mastering setup screen. For robot group, we're going to select 1. That is a group where we have the robot number 1. The number of measurement poses is going to be 27. That's by default. The work tool frame number is going to be 9. That's the user tool where we have the camera. The work tool frame number is going to be a temporary user tool for the vision mastering calibration. In this case, we select the default user tool, that is number 9. We're going to split up the screen. On the second screen, we're going to go to data, and we're going to select position registers. We're going to use 2 position registers, position register 1 and position register 2. We're going to give it a name. We're going to call it robot 1 home position. And we're going to select the second position register, and we're going to call it robot 1 vision master reference position. We're going to record the positions, so we're going to press Shift, record, and we're going to do the same with position register number 2. We're going to go to the left side, and we're going to select create program. We're going to press select. The teach pendant is going to display a measurement program generation screen as is showing here. And in here we have another setup screen for the program. We're going to select the camera type. We're going to press choice. And from the menu, we're going to select Air Vision camera. We're going to select this camera type when we're using the Kowa monochrome camera SC130EF2. This is only for the R30IB Plus controller or a camera for Air Vision. We're going to scroll down. This is a camera that we have selected. This is going to be the focal distance. The grid spacing is going to be 30 millimeters. We're going to press preview. We're going to press display image. And on the right plane is going to show the vision runtime. We're going to select the create program again. We're going to scroll down and we're going to select the exposure time in milliseconds for the vision measurement. For the image trigger, you can change the value. The Kowa is a high resolution camera, so it's going to take more time to take the pictures and process the image. If you want to reduce the time, you can increase the value of the image trimming to 50%. I'm going to leave the default value that is showing in here. We're going to scroll down. The reference pose shows uninitialized. We're going to press Shift and record to record the position. And it's going to show recorded. We're going to scroll down and we're going to select the measure camera position. We're going to press Shift coordinates. We're going to make sure that we're using the user tool number 9. And now we're going to press Shift plus execute. Just make sure that you have a speed that is slow. In this case, that's set to 10%, but something between 10 and 30% should be okay. You're going to see now that the robot starts moving and taking pictures. You can see the camera runtime on the right pane. You're going to see that the camera starts moving and taking pictures on different angles. When the process is done, we're going to have the result for the camera position and the calibration grid position. On step number 9, you can change the swing angle for the yaw, pitch and roll. You can restrict the movement or you can make it bigger. The bigger the angle, the more accurate will be the result. We're going to change the angle to 30 degrees. We're going to select create program and we're going to press Shift execute. It will show done and the program is created. Also, we're going to have the evaluation index of the program, and this is an indication of how good the result is. If you have a value bigger than 4.2, change the swing angle or increase the standoff distance for the camera and create the program again. We're going to press select, and we're going to have two files, that is the vmaster 11 and vmaster data 11. You notice that there are going to be two numbers. The first digit represents the group number, and the second digit represents the payload number. We're going to go back to the vision mastering screen. We're going to press preview. We're going to select the line number 5. That's going to be run the program. We're going to press select. We're going to set the speed to 30%. And we're going to press shift and forward to run the program. Notice that you need to keep the shift button pressed all the time, otherwise the program is going to stop. This program is going to take some time, as I have to take 194 steps. When the program finishes the execution, we're going to go back to the vision mastering screen. And you're going to notice that on line number 5 for run, it's going to show done. We're going to select the update master CT. We're going to press select. Again, the evaluation index program is an index number that is telling us how good the result is. The smaller the number, the better the result. And we want to make sure that the number is smaller than 4.2. If the number is bigger than 4.2, we go back to the settings screen and increase the swing angle. And you might have to also increase the standoff distance, and then you will need to regenerate the program and run it again. So in this case, I think we're good with this number. We need to update the master counts. So we're going to press shift and update. It's going to show the mastering data is updated. We're going to press preview, and we're going to have the step number 6, update master counts, done. We're going to select view result. We're going to press select. We're going to press next page, and in here it's going to show you the master counts with the original values and the new values. We're going to select preview again, and we're going to select the vision update log, and we're going to press select. And here you're going to have an update log with the date and time. And with this, we have concluded with the vision mastering for Robo 1. Still, we need to do the vision mastering for Robo 2, and it's going to be exactly the same process. In this case, I'm just going to show you the result for the mastering on Robo 2. I rotated the work cell 180 degrees. So now we have Robo 2 on the right and Robo 1 on the left. And also I moved the table 500 millimeters to the left. I deleted the camera from Robo 1, and I connected the camera to Robo 2 on the user tool number 9. I repeated exactly the same process for the vision mastering. We're going to have the program vision mastering 21 and vision mastering data 21. And after executing the program, we're going to have the results for the master counts. Now, going back to the setup list, we finished with step number 5. We did the mastering and calibration of Robo 1 and Robo 2. I'm going to conclude with this part of the video over here. We just finished with the very first steps of settings needed for the coordinated motion. In this case, since coordinated motion requires very precise movements, it's very important that we do the robot mastering using our calibration to get a more accurate result. On the next part of the video, we're going to continue with the setup, and still there are a lot of things to do. For now, I'm going to finish over here, and thank you for watching.